Hi, welcome to lesson 10 of arc sectors and angles and circles. Today we will be looking at angles formed in semicircles. So let's pause the video and have a go at these starter questions for a minute or two, please. Okay, let's look at how we would approach these. So question 1, we're being asked to calculate the size of angle X, so we need to remember back to our angle properties. In the first question, we have a right-angled triangle with a second angle of 37 degrees. So all we need to do is add these two angles together and take the total away from 180 because the three angles in any triangle add up to 180 degrees, and we get 53 degrees. For example B, we have a right-angled triangle again, but the base has been extended and we have been given an external angle of 131 degrees. So the first thing we need to do is look at the straight angle at the vertex with 131 degrees. A straight angle is equal to 180 degrees. So we do 180, take away 131, and this gives us 49 degrees at the vertex inside the triangle. If we add this internal angle of 49 degrees to the right angle, we get 139 degrees as a total. And then lastly, take 139 degrees away from 180 degrees in the triangle, and we get 41 degrees for angle X. For question 2, again, we have two right-angled triangles, but this time we know two sides and being asked to find the third side of the angle, so our method is Pythagoras. So looking at example A, the side opposite the right angle is known, so that means X is one of the shorter sides, so we have to use the subtract version of Pythagoras. Putting in our values, X squared is equal to 42 squared, take away 37 squared. Using the calculator, we get 395 for that. And then remember to square root that value. So X is equal to 19.87 millimetres. In the second example, X is opposite the right angle, so X is the longest side, the hypotenuse this time, so we're going to use the add version of Pythagoras. Putting in our values, we get X squared is 101 squared plus 74 squared. On the calculator, that gives us a total of 15,677. Then lastly, square root that value and we get X is equal to 125.21 metres. Okay, let's look at today's lesson. So today we're going to be looking at finding the missing angles and unknown lengths formed inside a semicircle this time. By the end of today's lesson, we should be able to identify the type of triangle in a semicircle, apply angle and triangle properties to find unknown angles in the semicircle, and use Pythagoras' theorem to find an unknown length. So let's have a wee look. So you don't have to copy anything on the next three slides, just have a look first. So we have a circle shown, AB is a diameter, so that means it passes through the centre. A third point on the circumference C forms a triangle with AB. If we measure the angle ACB, we find that angle ACB is equal to 90 degrees. Now we're going to try a second example. So if we change the position of C, and then we're going to measure angle ACB again. So we can see that the point C is in a different position in the circumference. So let's measure that angle. So angle ACB, and we can see from the protractor that angle ACB is 90 degrees again. Let's try this one last time. So again, we can see C has been moved to a completely different position again. And if we measure the angle ACB, so have a look at the protractor, you can see yet again the angle ACB is equal to 90 degrees. We could have done that several more times and our conclusion would just have been the same, that angle ACB was equal to 90 degrees. Please make sure you copy the following information into your notes. So our conclusion from what we've seen is that any triangle in a semicircle is a right-angled triangle. The diameter is equal to the hypotenuse of the right-angled triangle. And remember, the right angle is always opposite the hypotenuse, so therefore the right angle is always opposite the diameter. Again, can you pause the video please and copy the revision of angle properties into your notes jotter? It's important information that you need to remember for the following questions. So we have the straight angle is equal to 180 degrees. Opposite angles when two lines cross are equal, and also the total of the angles around any point is 360 degrees. Three angles in any triangle add up to 180 degrees. F angles are equal. The proper name for F angles is corresponding angles. And Z angles are also equal. The proper name for Z angles is alternate angles. Let's look at a couple of examples then with triangles and semicircles. So example A, the first thing to do if you have a triangle in a semicircle is to put in the right angle triangle. So mark in the right angle triangle on the diagram. So I would always sketch the diagram first. Next, we want to find X. X is the third angle in a right angled triangle, so we need to add the right angle and the known angle together. So in this case, 90 plus 67, and that's equal to 157 degrees. Then all we have to do is take that total away from 180 degrees. So we're using the fact that three angles in a triangle add up to 180 degrees, and that leaves us with 23 degrees for angle X. The second example B, we have a right-angled triangle inside the semicircle, but the diameter has been extended outside the semicircle, and we have been given an obtuse angle of 148 degrees outside the right-angled triangle. So we're going to use this fact that we have a straight angle at vertex B to work out the internal angle at vertex B. So a straight angle is 180 degrees, so we do 180 take away 148, and that gives us 32 degrees as the internal angle at vertex B. Then similar to A, we add the right angle to 32 degrees, and that gives us a total of 122 degrees. And because three angles in a triangle add up to 180, we take that total away from 180 to give us 58 degrees for X. For example C, we have a right-angled triangle inside the semicircle again, but this time both the diameter and CB have been extended. So this creates opposite angles at vertex B. But we also have straight angles at vertex B. So the first thing we can do is 180 take away 128 equals 152 degrees. So the obtuse angle of vertex B is 152 degrees. Then we can fill in our opposite angles. So we end up with 28 degrees as the internal angle in the triangle at vertex B. Now we can add the 28 degrees to the 90 degrees to give us 118 in total, and take that value away from 180 degrees because three angles in a triangle add up to 180 degrees, and that gives us 62 degrees. Our last couple of examples, we're going to look at using Pythagoras within the right-angled triangle in the semicircle. So firstly, we would sketch the diagram and fill in the right angle. So we can see from this we have two sides of a right angled triangle and x is opposite the right angle. So we're going to use the add version of Pythagoras. So putting in our values, x squared is equal to 67 squared plus 43 squared. Using the calculator, we get 6,338. And remembering to square root that value, so x will equal 79.61 centimetres. If we look at the second value, so again, put in the right angle opposite the diameter. This time, x is on one of the shorter sides, so we would use the subtract version of Pythagoras. So putting in our values, x squared is 26 squared, take away 18 squared. That will give us 352, which we need to remember to square root, and our final value for x will be 18.76 millimetres. So now it's your turn. Complete the questions into your class jotter, making sure that you show working and all answers with appropriate units. And then, as you've done for all the lessons so far, check and correct your work at the end, please.